Welcome to week 2 of ENG 103, the introduction to the Internet of Things. This week we're going to look at the elements of a computer, the architecture of the computer. We'll look at binary numbers, the Raspberry Pi, and some basic programming elements. In this video, I'm going to go through the basic components of a computer. To do that, I'm going to use the von Neumann architecture, which is an architecture that has been around for quite a while, and it uses the concepts of a stored program computer, where the instruction data and the program data are stored in the same memory. The central processing circuit is called the CPU, or the central processing unit, and this is where the instructions of a computer program are executed. The arithmetic and logic operations are carried out by the ALU, the arithmetic logic unit, which sits inside this central processing unit. Inside is also a control unit, which tells the other components how to respond to the instructions from a program. There are a series of registers which are essentially high-speed storage registers, storage areas. There's the MAR, which is the memory address register, and this holds the memory location of data that needs to be accessed. There's the MDR, which is the memory data register, and this holds the data that is being transferred to or from memory. There's what's known as AC, or accumulator, and this is where immediate arithmetic and logic results are stored. And then there's the PC, which is the program counter, and this contains the address of the next instruction processing that occurs in the computer. There's also the memory unit. That can be the random access memory, known as RAM, or it can be the permanent memory, which is generally the hard drive, or any other memory type peripherals that you might add, for example, a USB stick. And of course, in computers we have an input device, your mouse, your keyboard, a pointer, and some kind of output device, generally a screen. So there are what's known as buses that connects all those internal components that sit within the CPU, the memory, and the input and output. So there's an overall system bus, and within that system bus, there's the control bus, the address bus, and a data bus. So we need to therefore understand how the memory operates. So as I alluded to previously, there are two main memory processors. There's the main internal memory, which is usually a silicon chip, and this enables data to be stored and retrieved very quickly. It's known as a volatile memory, and it can be erased and will be erased every time you turn off your computer. And there's the external memory, or the auxiliary memory, which is generally the hard drive, the USB memory stick, an SD memory card, CD, DVD, ROMs, etc. So the difference between the RAM and ROM then, the read access memory for the RAM, or the ROM, which is read-only memory, is that the RAM is generally or is the data storage that can be accessed randomly at any time and in any order from any physical location. But the ROM is a form of storage that cannot be easily altered or reprogrammed. So generally you use the RAM to read data quickly, to run applications, and it allows you to read and write data to or from the RAM area. The ROM, on the other hand, stores the program required to initially boot the computer, and it only allows you to read the data, as it suggests by read-only memory. So as I mentioned, the RAM is volatile, that is, its contents are lost when the device is powered off, but the ROM is non-volatile, and the contents are retained even when the device is powered off. There are two types of RAM, there's static RAM and dynamic RAM, and there's several types of ROM. There's PROM, EPROM, and EEPROM. Don't worry about those different types of ROM or RAM for now. It's just to give you a bit of an overview of the general architecture of a computing system. In the next video, I'll go through how the data stores the memory and the use of binary numbers.